Here's another vector review topic that sometimes causes confusion. In fact, I'm just going to go ahead and pull this right out of the book, number 28. It has two forces acting on the same object. A 16-pound force, and that's directed at a 30-degree angle down from the x-axis, and a 20-pound force directed at 45 degrees upward from the axis. And they want to find, it says find the resultant force. Now that's a funky kind of word. Resultant, resulting would be something would be a little more like English. And there's two things to say about it. One is, it's just the sum. Mathematically, it just means add these two vectors. And so in a way, it's like, well, that's a silly word. It just should be the sum. But there's also something more to be said about it, which is that who says that if one person pulls on an object in this direction, suppose this is like a block on ice or something like that, so there's no friction, and somebody's pulling it this way with a certain force, and somebody's pulling it this way with a certain force. Who says that the combination of those two forces, two people are doing different things to an object, why should it be true that we can pretend that it's the same as if just one person was pulling by one force vector? That's a very profound fact of nature. It's called a superposition principle, is that you don't have to treat this super differently, and that these two forces don't combine in some extremely complicated way. They combine in about the simplest ways that quantities with magnitude and direction could possibly combine, which is vector addition. So in fact, we get, this really shouldn't look like a rectangle, but that's just my bad drawing. Graphically, we can say roughly the resultant force is just the sum of these two forces. And again, this is a profound thing. It says that if you look at what this block is going to do because of these two people pulling on it, it's as if one person pulls on it with the sum of the vectors. And that's a really deep thing. There's a lot of things in physics that do work that way, and then there's a lot of things in physics that don't work that way. And it's a huge thing when it works. So this is a great use of components. If we wanted to take these numbers, 16, 30, 20, 45, just combine them directly, it's not going to work really well to figure out this guy. It turns into like the law of cosines type of problem. So we're going to do it in a little bit of a roundabout way. We're going to say that F1 here, or did they name them? Nope, they didn't. Let's call that F1 and that F2. We're going to say that F1, we're going to express it in components instead of magnitude and direction. But we know how to do that. 16 cosine 30, 16 sine 30, which is 8 root 3, comma 8. Oh, and it's a minus 30. Haha. Got to remember orientations. That's negative. I caught my error because I knew this was going down, and that should have been negative. So it is. Then this guy is 20 cosine 45, 20 sine 45. I hope this chalk is, I'm trying to write bold, but I don't have my thick chalk today. So that's going to be 10 root 2, 10 root 2. Same in each direction because it's a 45 degree angle. And then F1 plus F2 is the resultant force. And that's easy. The whole point of putting it in components, most of the point, was to make this step easy. Combining them is almost trivial. It's just 8 root 3 plus 10 root 2, and then 10 root 2 minus 8. So if we were satisfied with the component version, we'd be done. But we really want the magnitude and direction of that guy. Okay, so just because I don't have a calculator, and just to cut it off, let's just say this is, just to make it a little quicker. We can calculate that, A comma B, so that's going to be A, that's going to be B. And the magnitude of F res. To finish it off, all you have to do is take the square root of A squared plus B squared. That's how much force. It's as if that much force was being applied to the thing. And then, of course, to get the direction, it's going to be take the inverse tangent of b over a. Let's at least look at the general shape of the numbers. These guys added together, so we get a pretty big positive number, and then 10 root 2 minus 8, that's definitely positive. 10 root 2 is about 14 minus 8 is 6. So it's definitely going upward. So our picture was fairly accurate, even though I wasn't being very careful. It's going far to the right and a bit up. And so it's as if that force were acting on the object. So notice the 3 steps. We converted magnitude and direction to components. We added in components, which is easy, and then we convert back to magnitude and direction. Although I didn't show you that explicitly because I didn't have a calculator.